All right, so for today's lesson 23 and 24, we are learning about what a polynomial identity is. A polynomial identity is simply an equation or a statement in which both the left-hand side and the right-hand side simplify to the exact same thing. In other words, they're equivalent expressions. The left-hand side and the right-hand side are equivalent expressions. If they are equivalent, then it's an identity. If they're not, then it's not an identity. How do we prove or determine whether a statement is an identity or not? We do it by algebra. We simplify the left-hand side as much as we can, and we simplify the right-hand side as much as we can. And then if we get the same expression, then the overall equation is an identity. If we don't, then it's not an identity. The important thing I want to note is this note at the bottom of the lesson note slide, and this is going to come up in your test later this week. Simply plugging in numbers does not prove, is not a valid way of proving whether a statement is an identity or not. Okay. We can plug in a bunch of numbers and calculate it, and it'll either work or it won't work. But in order to prove mathematically that it's an identity, we have to do the algebra. Okay? We need to prove that it works for all combinations of numbers. Plugging in a bunch of numbers only proves that it works for that specific combination of numbers. Doing the algebra and simplifying and seeing whether you get the same thing or not, that will prove or disprove whether it works for all combinations of numbers. I can't stress how important this is. Again, this will come up on your test later this week. As far as what we're doing today we are just going to prove whether an equation or a statement is an identity or not. So let's take a look at number 1. X minus 1, x squared plus x plus 1 equals x cubed minus 1. Notice, if you look at the right-hand side, notice the right-hand side is already simplified already. There's no like terms to combine. There's nothing we can do. So the right-hand side is actually already simplified. We do need to simplify the left-hand side. Okay, this needs to be simplified. And the way we're going to do that is by using the box method, which we should know how to do already. So x squared plus x plus 1. So let's do this really quick. This is x times x squared is going to be x cubed. X times x is going to be x squared. X times 1 is going to be 1x. Bottom row, negative 1 times x squared is going to be negative 1x squared. Negative 1 times x is going to be negative x. And negative 1 times 1 is going to be negative 1. And if we write this out, we're going to have x cubed. For this first diagonal here, we have x squared plus negative x squared. Those are actually going to cancel each other out. And actually, the same thing happens in the other diagonal. X and negative x cancels each other out. So we're left with x squared minus 1. And notice we get the same thing on the left-hand side when we simplify as we have on the right-hand side. That is what I mean by equivalent expressions. We literally get the same thing. So to answer the question, is this equation, is this statement an identity? The answer is yes, it is.